Um, Welcome to this session, Rag to Riches. I have playfully kept the title Rag to Riches. Rag, obviously, is a pun on rag, and rag to riches is a phrase which means going from poverty to extreme wealth. Today, there is some truth to that. The technology that we call retrieval augmented generation, the field, it's become a field of its own, is become the dominant generative AI application. If you look at ChatGPT, it started out as a chatbot in November of 2022. It was a research project, and you could tell that it was a research project because OpenAI, when they released it, it had the most basic UI, just an input box and output text. And who puts input box below the output text? Right? Uh, well, researchers make such UIs, and it did that. And yet, ChatGPT became such a powerful thing. It had the world's most amazing adoption curve. It catapulted what was AI, what was transformers or language models, as a playthings of researchers and select group of engineers. It catapulted it to something that became a household name and a household utility. Nevertheless, it started out as a generative model. You would ask it questions, it would answer. But over time, you notice that it has now become a full blown agentic RAG system. Now, what do I mean by agentic RAG system? Now, ChatGPT is a complex architecture. It contains a lot, and therefore, it is a simplified approximation to say that it is an agentic RAG system, but it certainly is that, at least. What do we mean by that? It searches the web, it finds information, and then it answers your question if it is not able to answer your question. Perplexity is the poster child of RAG. If you think about it, who would have dared to challenge Google for search? And yet Perplexity came, and when it landed, vast majority of us practically stopped using Bing or Google or any of the other search engines, and we moved to Perplexity. Would you agree with that? Or, well, now Perplexity has competitors because ChatGPT has become exactly that. And Google, not to be left behind, said, hey, if you can do it, we can do it better. Right? So they have caught up with their Gemini. And then the open source community has also caught up. Uh, all of these, when you look around, are RAG systems. So, and of course, the token, the amount of utilization that these people are having is more than doubling every year. It's an exponential growth. And that gives meaning to this phrase, rag to riches. We are going to talk about rag to riches. Now, a little bit about this 2-day course, which I give every about once or twice a year. It's a prelude to a bigger course called Advanced RAG and AI Search, uh, best practices and advanced techniques, or something like that, is there on our course portal, which is a much more technical and advanced course. But this particular 2-day series we do, it's an invitation to learn this subject. I'll talk about the foundational theory. We'll do some lab, enough that you can run with the code and actually build something useful with it in your favorite domain, favorite corpus of documents, favorite images. You can actually do. People in the past have used this to create good family albums of pictures, and they have used it to make travelogues, right? And so forth. So use it for what you will. There is a joke I usually start this course with, and I'll do that. The story goes that a person has done equal amounts of good and evil in the world. So when he dies, the bureaucracy up there is unable to decide whether to send this person to heaven or to hell. So they say, why don't you decide on your own? So he goes to heaven and he sees people are very devout to God. They are singing hymns, bhajans, right? Praising God and doing all sorts of noble things. And he gets a little bit bored with that. So he says, let me go try out hell. He comes to hell and he finds excellent coffee. I hope you can smell it, right? Excellent conversations, right? Very interesting people. So after a little while, he comes back and he talks to the bureaucracy and says, "Yeah, I've thought a lot about it. I think I'll go to hell." And the moment he goes back to hell, the devil is waiting there with a big stick. The coffee is cold, the temperature is high, and he's given a sound beating. Then he says, "Why?" He says, "Well," devil says, "Well, yesterday was advertisement, now is reality. Before you were a guest, and now you're part of us." So I mention this because uh, these two sessions, think of it as your advertisement. The main course is where the technical depth is. I jokingly call it the hell. We are prepared for you. But if you go through that fire of hell from the much more extensive course, I promise you, you'll come out forged as steel. You'll come out quite literally at the top of your field. And I don't say that lightly. This is a vast field. To claim that we can take people and put them technically at the top of the game in this field is either a vacuous claim or a claim that we mean very seriously and we know how to take you there. I'll leave it for you to decide which of the two realities is more likely. But today and tomorrow, it will just be an invitation to this beautiful and very, very powerful field that we call retrieval augmented generation. So, when we talk of retrieval augmented generation, the analogy comes to me of we are here in California. There was the gold rush. I don't know how many of you are intimately familiar with the history of the Wild West. When gold was discovered in California, everybody and his brother got into a wagon and started heading west. They all came to California. They came on horses, they came in wagons, they came by whatever means they could. Because they all knew that it is gold and it's a land grab. Yet very few people actually got rich from the gold. Most, most people were spending countless hours by the stream looking for little nuggets. The people who succeeded were few. They could operate at scale. They could think large logistics, the implications of vast engineering at scale. And those people, because they had the technological advantage, because they had the advantage of vision, of already anticipating how difficult it is to mine gold, they were the winners. The lesson there was those who knew the problem is harder than it looks were the winners. And they rapidly accumulated wealth, and that wealth became a generator of more you know, power to grab land and find gold. With the AI and generative AI world, I cannot help notice that the same thing is happening. As generative AI comes in, the vast majority of us, I call us the peasants, we are all celebrating how easy it is. Look at it. What it would take me a month to do, now I can sit with Cloud Code or Gemini or Codex, OpenAI Codex, and it writes the whole code for me. How easy it is. Everything has become extremely easy. Everything looks easy, right? And that has its own dangers. Very much like the gold rush, it has the risk that it causes its own epidemic of laziness. If you believe something is easy, you won't put effort into it. You think I know it. But the biggest block to progress is to know that you know, when in reality, you don't know much. And life doesn't spare you. Business world doesn't spare you. Your career depends on having a competitive advantage, always. So you will see that this subject, which looks deceptively simple, is extraordinarily complex. It is not a topic in generative AI. It is the dominant field that has emerged. When it started in 2023 early, I used to think that I could read every significant research paper on RAG. I had a network of people, and we used to sync up informally every day. What have you learned today? What have we, oh, which paper is more interesting? And we would jointly have a paper reading sessions. By the way, it continues. Every Wednesday, we do research paper reading here at Support Vectors. That tradition is going on. A lot of the papers were RAG, and we thought we were on top of the game. Soon we were not. Hundreds of papers came out. Then thousands of papers came out. And it isn't that they are all making tiny incremental progress. Even now, every day when you think this subject, or the common people think that, oh, this subject is easy and a done deal. I've even heard phrases saying that, oh, RAG is over. It's no more the frontier. Obviously, they are not cognizant of the emerging research because almost every day, one more paper lands that is a substantive breakthrough on this very, very hard topic that is RAG. If the subject was closed, there wouldn't be any scope for research at all. And yet, remarkable papers are coming in torrential amounts. They're raining on us all the time. So, if there is a lesson that I want you to take away from today, it is that this subject is not, not as simple as it looks, but it is perhaps the most complex technological marvel that we know of. It's extremely complex. And most of the things that run the world are RAG systems now. Your Google search is a RAG system. Perplexity is RAG. ChatGPT is RAG. Cloud is RAG. Gemini is RAG. DeepSeek's portal. Lot of these tools are RAG. And when we teach people how to build RAG, almost everybody comes to the class saying that we know what RAG is. We have already built it. We have used this open source library and that open source library. And it just took us 2 hours to build something very useful. That is the danger. It's deceptively simple. RAG is not about libraries. It's a deep subject that needs careful study. You have to approach it with patience, humility, and a tremendous amount of hard work. So I will start with that message and I'm going to end with that message. Now, with that, I'll start with this. See, RAG is supposed to be built of 2 core pieces. In a very simplified world, it is search results on which you screw in a large language model, a generator. First part is retrieval, second part is generation. So retrieval and generation. Retrieval, augmented generation is the phrase. And we'll look into where this phrase came from. Right? Where is it coming from? But for a moment, I'll step back. And if you will allow me, I'll take a more civilizational context to put it in perspective. Why do I believe that RAG is front and central to our civilization itself and to modern technology? So, humor me with a small historical journey. See, I go hiking every morning while it is still dark. I go through fairly forested areas. I go all the way to the bay. It's not complete wilderness. It's not that I'm 100 miles from civilization. I'm very much getting out of bed and getting out hiking. Nevertheless, on that trail, there are coyotes, lots of them. There are bobcats I meet regularly. There are raptors, eagles, and hawks. There are, and when there's wildfire, as happens in September, October season sometimes, and the habitat of the mountain lions are disturbed, sometimes they descend upon my trail. They're snakes. Nevertheless, we walk on that trail, and many other people walk on that trail when it is still dark. They start when the stars are shining. It makes you wonder, how is it that human beings, if you think about it, I don't have claws. If a bobcat came at me or a mountain lion came at me, don't have claws. I don't have horns like a bull. We have no defenses. Humans as a species, Homo sapiens, has no defense. Nevertheless, this species has been extraordinarily successful on this planet. Would you agree? And it has certainly transformed this planet in more ways than perhaps any other species on Earth, right? And how is that possible? What is a survival predicated on? What is the key differentiating advantage that Homo sapiens have over the lion with its might and its roar and its muscles, or over the fast tiger? See, their knowledge of survival is passed down through the DNA, through instinct. When a duck is born, it more or less knows how to swim in the water. Right? When a tiger cub is born, it knows its place in the ecosystem. Instinctively is there baked into its DNA. But human beings actually are born, almost all of you have seen little newborn children. They are hapless little creatures, no chance of surviving at all on their own, with no knowledge. So, what has caused our survival? Humans survive because we have it, we collect our experience as knowledge, and we tend to transmit it down to the next generation. We have oral traditions, we formulate language, and those languages are the carriers, the vehicles that transmit from generation to generation all our knowledge about survival. Would you agree? If you go back and look at the prehistoric caves, you will see etched on the wall what our ancestors wrote in pictographic form. And there is a problem though with knowledge. The more knowledge you have, the better chance there is that you'll survive. The more efficient you'll be at survival as a tribe. But knowledge has a problem. Our mind is of limited capacity. More than that, our minds are leaky buckets. How many of you can precisely recall what you were doing at 4:25 p.m. last Wednesday? It's disappeared because the mind does abstractive summarization. It makes sense of facts and events, and that the meaning that it extracts, it preserves, and it discards the facts like oranges from which you have squeezed the juice out. But this meaning, this knowledge, this experience, we keep transmitting from generation to generation. We need a way to do that. As knowledge grows, you can see the rise of and fall of civilizations associated with this knowledge. One of the most remarkable facts of history, either by coincidence or by causality, is the great library of Alexandria. In Egypt, the oldest human civilization, they realized that knowledge was growing exponentially even then, thousands of years ago. So they sent people all over the world to learn whatever each civilization had learned, to gather all of that knowledge into the Library of Alexandria. And so it was done. But Library of Alexandria had a system. You could walk into the library. It had an indexing system. And of course, in modern libraries, you have the Dewey indexing system. How many of you are familiar with Dewey indexing system when you go to the library? You see it on the spine of the book. You see those numbers? What do? They can tell you this department, this subject, this title, or this theme, this authors are here. So knowledge has to be systematized, cataloged, preserved, and made easily accessible. Otherwise, that knowledge is not of much use. And that is what libraries do. As the great library of Alexandria got burnt in Egypt, and likewise in India, in many thousand years later, would be equivalent catastrophes. The burning of the Nalanda University, and so forth. You could literally see whether it was Egyptian, the Western civilization, or in the Indian civilization. There was a remarkable decline. There was a remarkable decline in civilization. In Europe, there was the coming of dark ages. In India, the medieval ages are not one of our proudest moments. So, civilizations rise and fall with their ability to curate knowledge and to make the knowledge accessible when you need it. It's a lesson of history. As the computer age came through, the great libraries became the great search engines. Knowledge was there as web pages, it was distributed haphazard all over the world. If the world was just busy creating knowledge, but you couldn't find that knowledge, for all you care, might as well not exist. That is the central role of search. Because without search engine, you really cannot have modern civilization. Knowledge is too vast now to capture in a Dewey indexing system and too vast to be stored in a Library of Congress or anywhere. What is more, knowledge is increasing exponentially. Here is a fact: more knowledge will be created in the next 2 years than in the entire history of mankind since prehistoric times. Just think about it. All our science, all our technology, all our medicine, our literature, our poetry, our histories, everything that we are proud of, the sum total of it all, more knowledge will get created in the next 2 years. So that's an exponential growth. And human mind always has trouble dealing with exponential growth. That should give you some sense of understanding of what mighty technology it takes to genuinely be able to create a search that can span this exponentially growing landscape of knowledge. You realize that, guys? And that field of search, formally in computer science, has been called information retrieval or the retrieval industry. And so the word retrieval is the formalization of that term search. But we'll colloquially use the word search. The reason I mention it is everything starts with search. Knowledge being there, if you cannot find the precise bit of knowledge, it is not of much use, isn't it? So, that. Now, the history of the field is this: people have been trying to search, but there was a problem. How do you search for things? And there are two, and I'll give you it in broad strokes, and then we'll drill down a little bit with examples. There are two generations of search engines. One is how it was practiced all the way to 2018. It today, we would call it keyword search or sparse indexes or inverted indices. I'll give you a flavor of that. All the way till 2018, as you know, powerful search engines existed. First, there was Yahoo Search and Alta Vista. Anyone remembers those? Graybeards in the class remembering those? Right? Yes. Right? Yes. And then came Google and essentially wiped the slate clean. Right? Google has been a mighty search engine. And not many people realize that despite the amazing technical excellence of the search platform that Google created, nevertheless, in 2018, there was something tantamount to a reinvention, a complete reinventing of the search industry. And that is the moment that marks the beginning of this topic that we call retrieval augmented generation. Are you together? And what I'm going to do is illustrate the before and after for you. And I'll explain what was the problem with the search before in hindsight. In hindsight, of course, we all see it 2020, isn't it? But today we can see the limitations. It wasn't so obvious then. And then we can see what does AI bring to the table? The so-called language models, what do they do? And that is where we'll focus today. And then gradually we'll move towards practical applications. As I said, today will be all about understanding, making sense of it, finding meaning. In the next session, it will all be coding and labs, which is tomorrow. The code is already waiting for you. It's on our public GitHub. So with that, I tend to not bring slides, but we'll develop our thoughts together. How about that? Let's see. Is something visible? Okay, we'll start with that. Let's start with a good smile. So, see, suppose, imagine a simplified world. There are 3 documents or 4 documents. There is a document, E1, the cow jumped over the moon. Of course, that's what cows do. Right? The full moon was shining over the meadow. D3, Apollo 11 was the first spacecraft to on the moon. And let's add a few more documents. Cows, ducks, and horses were grazing. Well, ducks don't graze. Cows and horses were grazing. Let's see. Okay. Cows and horses were grazing in the meadow. Let's take these 4 and imagine that you're not looking at 4 documents, but you're looking at 4 billion documents. Okay. So the old search, what is called keyword, by the way, old is derogatory. It's still very powerful and used. But let's say that the earlier discovered search framework would do this. It would say, let's identify the important words. So would you like to search for a document with the? Is the not much use, right? You can't imagine a document that doesn't have the word the, isn't it? So these are called stop words. You get rid of them. You don't care. But you look for so-called keywords. And you do, well, jump and jumped and jumping, they are related, right? The word that you use in natural language processing is that lemmatization yields the same root. Right? Over there. The moon may be full, was shining over the meadow, and let's say Apollo 11 was the first spacecraft, let's say, to land on the moon. And obviously, I'll be a little bit sloppy. And where are my horses? And horses. And horses were graze in the meadow. So far, so good, guys. Is there any other significant word that you would like to search documents with? When was the last time you went to Google and said, I'll search for the word the and see how many websites come? You don't, right? So those are called stop words. You don't care. So now, think about this. Suppose I created a table. You are all familiar with a hash table, isn't it? A locker room. If you are not, then think of a locker room. What happens in a locker room? You give your suitcase, they give you a token, the key. Then, unless you come back with the key, you don't get back your suitcase, isn't it? That concept is reified in computer science as the concept of a hash table, a map, and other things, hash map, etc. There are many words for it. Dictionary. Dictionary is perhaps most intuitive. The word is the key, and if you want to know its meaning, it's sitting there. Right? So what you will do is we will create an interesting dictionary. We'll say the word cow and see how many documents have cow in them. Could you tell me which are the documents with cow? And D4, right? And the next one, jump. What about that? D1. And if you look at the word moon, D1, D2, D3, right? Now, we can go on. Apollo 11 would be just D3, isn't it? Spacecraft will also be just D3, right? Grays would be D4, horse would be D4. So suppose I were to give two words. If I were to give the word cow, does it make sense that you would return D1 and D2 documents as search results? Right? But if I were to give you the words the cow and the horse, what would your instinct be? Right? You would bring back D1 and D4, but lean more heavily for D4. Prioritize D4, isn't it, in your search results? You'll bubble it to the top as more relevant. And that, in simplified, that's the kernel idea of the search engines as they have existed. Now, while it looks simple, to implement it at engineering scale is a entirely different game, right? That's the world of big data and scalable computing. When you have to do this at planet scale and maintain massive dictionaries like this. The word that people use for this is inverted index. You realize that here, the word cow will bring up the documents that contain cow. Right? It's an inverted index. And today, in today's language, what you will say is that you're doing sparse index. For reasons that you will see shortly, we call it a sparse index. Now, this is one half the journey. The second half the journey is, given certain keywords, how do you find which ones to bring to the top? Right? What is the ordering of those documents that match your query? That is important. So relevance, and there were many algorithms and heuristics for ordering the results. A lot of research was done on the relevance aspect of it. So what has happened is that the research that was done on the relevance aspect of it, a lot of them are deep ideas that are more universally applicable than just the inverted index approach. This inverted index approach, today we call it keyword search engines. So many of you were familiar with Lucene. How many of you know what that is? Lucene, Solr, Elasticsearch. They were all keyword search engines, and so was Google or Bing. Right? But Google and Bing did it for the web, and at a planet scale compute, Elasticsearch that you installed or Solr that you installed did it at your corporate scale. But there is something, so there's two aspects to it that are worth noticing. See, if you look at this dictionary as a person, you're not asking it to give you document 1 and document 4. You're not giving it the key. You're saying, I'll tell you the name of the documents. You give me the content. Is that what you say to a search engine? No. You don't know the documents. You instead go to it with keywords. Right? In neurocognition, we call it associative memory. Right? See, I'll give you an illustration. A lot of us love food. My love for food is visible, right? So, but food is memory. A lot of the time, the food that we eat not just for the flavor, the taste of the food, because tied with it are deep memories of our grandmother fondly serving us that food, of our of all the elders who have loved us and expressed that love through that food. Would you agree? Right? You may have gone to a fair as a child and have had happy memories and gone on a merry-go-round. Even today, when you see a merry-go-round, immediately it evokes childhood memories, fond memories. That is associative memory. You're not retrieving your memory by saying, on this particular date, this happened, isn't it? By a keyword, by a timestamp. You're retrieving the memory by association. Certain things create association to other groups of memories that sort of bubble to the top. Right? That concept of associative memory is one of the deeper concepts in our field. So if you look at it like that, your inverted search index, do you see that it follows the norm or it fulfills the definition of associative memory? You're not asking for a document by ID. You don't know the ID. Who knows the URL? If you knew the URL, why would you go to a search engine? You would go directly to that web page. But you're invoking it by keywords. That was the strength of keyword search. There was also a limitation to keyword search industry. The limitation is this: human beings don't communicate through keywords. Right? So, for example, I have a magical tendency to lose my keys or my wallet, right? Or my cell phone every single day. Right? So imagine waking up in the morning and just shouting, keys, keys, keys. It would be hard for people to understand what is it that I mean by keys, right? It's a keyword. It doesn't cause the keys to magically appear. But if I were to say, I've lost my keys, I don't know where it is, I just looked on my table, then your family members know what's going on. In other words, keywords don't convey context and purpose. Are you getting it? And yet, we have gotten used to, for decades, approaching Google or Bing or whatever with what? Keywords. That is its principal limitation. Keywords don't come with context, meaning, full purpose. Are we together? Now, there is also in English language and in every human language, a word is a bundle of many, many things. Many things are said when a word is spoken. There are layers of meaning hiding in there. And often it is the context of the word that illuminates its meaning. Right? For example, if you use the word bank, let's try the word bank. What does it mean? Financial bank. The Silicon Valley crowd, only financial bank. Right? So, financial bank, but it could also be a river bank. Right? It could be your a friend banking on you to bring your car back safely and not crash it, isn't it? Or more practically, banking on you to bring a delicious pizza, right? Banking on you. More meanings to bank. An aeroplane, when an aeroplane may turn, go ahead, the road banks. Have you noticed that when you make a sharp turn, the road has a pitch, an angle to it? It is the banking of the road. The reason at high speed you don't just fly off at a tangent is because the roads are engineered with a bank. So, road curvature angle. When an aeroplane is about to land, it turns and aligns with the runway. That is banking, aeroplane banking, right? Up. So, and we can go on. And the reason I said this is to illustrate that even common words such as bank have a lot of meaning. They have what linguists call homonyms and polysemy. Many meanings are there. So why is our language sort of overusing the same word for different contexts? It's a fact of life. It's there. Nonetheless, we don't get confused. Suppose I were to tell you, I am going to Wells Fargo to deposit my money. What would you, if you came to this country and had no idea what Wells Fargo is, what would you deduce about Wells Fargo? That it's a financial bank. And yet I did not use the word bank at all. Right? So there is a lesson here. The meaning of a word is not in fully in the word. So think of it like this. The word is there, the context is there that it is surrounded with. It is the context that imbues the word with meaning, isn't it? And sometimes very little intrinsic meaning need be there in the word itself. Suppose you had misspelled the word as bonk, in which case it is not just wrong. I mean, it's not just devoid of meaning, it's actually misleading. Right? And typos happen. Nonetheless, we survive with typos. The context clarifies the meaning. Spell checkers couldn't have fixed the typos except by looking at the context, isn't it? So, this is an interesting lesson. There is a continuum. Given a word, where is the meaning and the context? In this continuum, either 100% is here or 100% could be here. You may not use the word at all, and yet the meaning is there, isn't it? That's an interesting lesson. But what does that teach us? Where does that leave us with keyword search engines? You look up, you search by words. But if words are not fully imbued with their meaning, you realize that you are starting out with a handicap. You have an inherently compromised system for search. Is it making sense, guys? Right? That is a fundamental limitation of keyword search engines. So, what do we need? We need a search framework, a retrieval system that is context aware. Right? Just as in common sense, you don't holler at your family and says keys, keys, right? And they're all wondering that is it premature dementia? Instead, you explain in so many words what has happened. Right? You surround it with context. So why can't we talk to a search engine and give it a context? Well, that is Bayesian inference. Right? The family will infer just by the look on your face. Right? So one lesson to take away, the reason I took you on this digression, guys, is it's a watershed moment. The day you realize that keyword search engines, as they existed till 2018, were inherently compromised systems that you were retrofitting with all sorts of clever tricks to make it work. Do you see that? There is no getting around the fact that the meaning of a word is not always in the word. Therefore, how can keyword search engines be truly, absolutely effective? And you all must be remembering that search, even with the most powerful search engines, used to lead to a lot of irrelevant results, no matter what, isn't it? Some were better than others. Google was the king of search, doing much better. But they were bringing a lot of things to, after the fact, fix the system, right? And they did an incredible job. And then Lucene did an incredible job on which Solr and Elasticsearch are based. Nevertheless, foundationally, we need a change. Around 2017 came a landmark thing. And it is about, and to illustrate what it is, there are two concepts. If you get today, you will understand the heart of RAG. So I'm going to talk about it. One has to do with attention. So we'll understand two things. And if we understand that, the claim is to have understood that is to have understood this field. Attention. What is attention? And what is language model? These two things. So our journey, our next stop of the journey now will be to attend to these two concepts. Right? When we talk of attention, see, as I am speaking at this moment, many things are happening. There is the hum of the air conditioner, isn't it? There are other people, somebody is fidgeting in their chair. They are in their field of view, your field of view, right? If you are in the front row, you have the TV here and a TV here and all sorts of distractions, visual distractions, right? Your visual field and your auditory field is facing a deluge of inputs. Nevertheless, you're paying more emphasis to what I am saying. That differential emphasis on a input versus another input is attention. When you attend to something, what does it mean? You're giving it more of your mind. Does it make sense, guys? But what makes you give it more of your mind? What makes you attend to it? Why do you pay attention to something? No, concentration is a conscious act. Attention is different. See, let me get back to hiking and see if I can explain to you what attention is. When I start out in the dark, these days though, I've been a bit lazy, it's very cold. When I start out in the dark, because I like stars, where's my attention? At the stars. I'm looking at my old familiar face. Where's Cassiopeia? Where's Orion? Where's Sirius? Right? These days it's winter stars. Where's Pleiades? Right? And of course, where is the Big Dipper? I like that. To me, I like to ask questions. And to begin the day by seeing a big question mark in the sky as the Big Dipper and a big W asking why as Cassiopeia gives me a good start. So my mind is up there. Am I at that? But see, on the path that I'm walking, there are bushes, there are trees, there are birds in the trees, there are hawks, predators. There's potentially a snake or two crawling, right? There's a bobcat prowling in the bushes. There are coyotes howling, whose faint howls I'm sort of hearing in the distance. But my mind is in the stars. Why? Because you don't wake up when it is still dark at ungodly hours and go out hiking in the cold unless you really like seeing stars, isn't it? So you want to maximize your attention to the stars and the moon. But now, after a little while, about 75 minutes before sunrise, the first light of dawn comes. You see a carpet of fog mist over the creek, over the river, over the creek, because I walk along a creek. Right? It's beautiful to see that, to see it gradually evaporate, to see the first light over the hills turn back. Where is my attention now? Is it in the sky or is it on the horizon or near the ground or the river? Focus has changed now, right? I'm attending to something else. But now you suddenly hear, wow. The moment you hear a growl, where is my attention now? It's the bushes. Where is it? Right? Your eyes are all over the place. What happened to the stars? They're yeah, they are there, but they're gone. Right? What happened to that beautiful mist on the river and the lovely light of dawn? It's there, but it's gone. Your mind is attending to and looking for the predator in the bushes. So, where is your attention now? And searching for predator. What is the context now? Survival, right? Because your survival is predicated in a proper assessment of risk, of danger, and where it is coming from, isn't it? So the lesson here is attention, two lessons to take away. Given multiple inputs that are impinging on you, given multiple inputs to the mind, it is the context that determines what you'll pay attention to, isn't it? In very simple terms, a businessman enters a bookstore and goes straight to the startup and entrepreneur section, right? And looks at finance books and uh, financial modeling, right? A poet enters a store and all those business books are still there, but the mind of the poet takes the poet to the literature section. Context is different, and context often defines, it comes from our underlying state of mind. Right? So we'll stay with that definition of attention. So a key value is, by the way, what I am saying is not poetic, it's not metaphorical. This is literally the math. And today we'll eschew math, but when you do the course, we will drill down into it in significant detail. Right? So what it is that suppose you have an input A1, AN. These are all the things in your input field. What happens is that you have a context, CTX. How much attention you give to each of the input depends on how aligned that input is to the context. Right? More mathematically, and let me just give you a tiny taste of that. It is literally alignment is measured mathematically as a dot product. You guys remember your dot products from school? Dot product. And so this dot product scales up attention given attention given to the ith input is conditioned by this. So it gets more attention given this summation over j. Those inputs that are much more aligned with the context are getting much more attention. Are we together? When my attention is survival, I'm looking for the predator in the bush. Right? That is attention. So we'll hold that thing in our mind. The second thing is, so now think about it. Why did I bring this attention into the story? If you are looking at a word and you know that the meaning of the word is not just in the word, but in the context, then that word becomes a piece of input, searching for its full meaning from the context, isn't it? Each word becomes sort of a query vector, a query input that's saying, given the context, what is my full meaning? It is in search of its full meaning. The machines that could do that came into existence in 2017. They were called transformers. In a beautiful and landmark, and perhaps the most cited paper in our field called Attention is All You Need. This paper is a celebrated paper, has countless citations in our field. And in fact, our field, generative AI, more or less starts in a very, or gets accelerated from this point. Generative AI has been there for a long time. First, there were the Hopfield networks, then there were restricted Boltzmann machines, there were variational autoencoders. For those of you who are steeped into neural network theory, you probably have heard these words. Some of you have attended my foundations class, so you know it. But if you don't know it, just imagine that there were prior predecessors to the transformer as generative models. But when the transformer was discovered, it would not be an exaggeration to say the world changed. But it took, but the change in the world was noticed only by the technical AI community. It really caught popular imagination when ChatGPT came around. So, what is this transformer? Transformer was the first architecture that crafted a language model, something called a language model, which had existed, but it crafted it using attention. Are we together? It said that to understand what a text says, let all the words find their real meaning, saturate themselves, soak themselves in the context, and sort of swell up with their real meaning. And then what the text itself is saying, semantically, the semantic burden of the text will become self evident in some sense. That's the core message of this architecture. But for that, we need to understand one more concept, which is that of the language model. What are language models? Everybody is talking about language model, large language model, small language model, this language model, and that language model. What is a language model? Have we asked that question? Anybody would like to volunteer? What is a language model? Next, predictor of next token. That's the popular definition of a language model. It falls far short of its true definition, but it's a good start. Anything else? Hey, we should, there's no penalty to guessing. Make wild guesses. Go ahead, please. That's a very good answer. Tries to understand what the user is saying, what the input is, and we'll build upon that idea. Anybody else? Can you do that? Yeah, you're familiar with some of the technical aspects. That's very good. Uh, uh, Hold that thought in your mind. You're not too far off, but we need to sharpen that thought. Anyone else? Oh, the cow jumped over the moon has a meaning, but is that a language model? Horse, hammer, plane, why is a question. Now, I'm deliberately giving you a counter examples, but all of you are thinking in the right direction. So let me illustrate it with a story. See, when you're young, you learn languages easily. So we all pick up 5, 6 languages in our childhood. I have picked it up. As you grow older, progressively it gets harder to pick up a language. Right? So I've been fighting a losing battle trying to learn Mandarin. Knowing that 1.4 billion people speak Mandarin, it behooves us to know what that culture is about. So I've tried and tried, and some days are wins, some are losses. But let us say I go to Shanghai. At my age, even if you, in quotes, learn to speak Mandarin temporarily or at the kindergarten level, what will happen is this: you will hear some Mandarin text, Mandarin spoken, and you will receive it. What will be the first thing you will do? What was he saying? And our mind will write it in, translate it into native tongue, because we each carry a native tongue in our mind, isn't it? For you, it's Tamil, right? So maybe you're immediately trying to relate it to this piece of uh, Chinese wisdom to one of the Tirukurals, right? Or if you're North Indian, Kabir's Doha or something like that. Right? We all translate it. We all write it in a, first thing we do is translate it. So let me put it the word, write it in a private diary. In what? In Mandarin or in native tongue? Native tongue. Let's say your native tongue is, for the sake of, let me see, look at the class. I think I see a predominance of Tamil, so it has to be Tamil, right? So let's say that you got it in Tamil, right? So then somebody says, this other person comes and says, you were asking for directions. You heard Mandarin. Now you need to explain it to your friend who is a North Indian, like me. So what do you need to do? You need to translate it into another language, to Hindi, for example, right? So you will, now for this process to happen efficiently, two things are essential. You should actually understand Mandarin. It should be a lossless capture of the semantics of Mandarin. In other words, we use the phrase lost in translation. What is a prerequisite for a good translator? There should be no loss in translation, lost in translation, isn't it? Or more technically, you need a lossless semantic capture, because it's always nice to use technical jargon, isn't it? Right? To say the same thing, lossless, but it's making it more precise, a lossless semantic capture. Because if it is lossy, there is no chance that the person who gets the Hindi version will get it. All of you are familiar with the game of telephones, isn't it? Even when children speak the same language, 5 hops later or 10 hops later, something completely different comes out. So, what is the medium? Is it a lossless semantic capture? No. Slowly, gently, the semantic keeps morphing into something else, isn't it? So, so this we will call a translator or an encoder, right? The the primary responsibility of an encoder is to do is to fulfill the ideal of lossless semantic capture. It will never quite achieve the ideal, but you want it to approximate the ideal as much as possible, isn't it? The quality, the measure, the metric by which you measure an encoder is to what extent it does a semantic lossless capture. True? Hold that thought in your mind. Now, this is the decoder. Assuming that you are fluent in Hindi and Tamil both, likewise, you should be able to translate it. But translation is not the only thing you do. If you were given the direction, or if the question in Mandarin was, are you feeling hungry? You don't want to tell the, uh, or maybe the person is, or it could be a question, or it could be, go to sleep now, right? Then what you say in Hindi may just be completely different, right? You may say, this guy is not letting me go to a movie. He's saying, go to sleep. Right? Kids would do that. So the decoder could be multiple things. Its purpose may be to find the sentiment in that. Children do it all the time. They listen to their parents and then to their sibling, they say, I think mom is angry. Right? They're not translating, but in a different way. They are doing a sentiment analysis, isn't it? So those are all things that you can do. Or you could stay within the same language. Somebody talked to you, asked you a question in Mandarin, you shake your head and understand it in Tamil, and then you try your best possible Mandarin and try to respond with that, isn't it? Right? So it may still be the same. But nevertheless, there is an intermediate representation, which is in your native tongue. This diary that I talk about may be a real diary. It may be actually a real diary that you write in. Or it, even if you don't write it, in your mind, mentally, there is a capture. There's a diary like capture, isn't it? So now the question to ask is, your native tongue is Tamil. What is the native tongue of machines, of AI? You have attended my class. Okay, so then I'll pose you this question. Why vectors? Why vectors? So it turns out that while we speak Tamil, machines speak Machinese. That's their native tongue, right? And Machinese is not a bunch of words, but it turns out it speaks as a points on a manifold, on a surface. That's very odd. Why would it want to talk as points on a surface? And the surface in particular that you should think of is a sphere. Think of a sphere. So you say something and it immediately translates it to a point on the sphere. Now, why point on the sphere? I would like to tell you about it. By the way, now, before I do that, why machines speak machine is made up of points on a sphere or a hypersphere. Let us park it for a moment. But let's go back to it. You realize that foundational to communication is this chain of encoder decoder, right? Do you agree, guys? This is called a sequence to sequence. Actually, the word should be two, but people they sequence to sequence right? Models, right? Or sequence to sequence architecture, or whatever you want to call it, fancy word. It is abbreviated in a cute sense to, so in research papers, you will say sec to sec. Literally means sequence to sequence. Means there's an encoder, there's a hidden representation, and there's a decoder. Now, strictly, the understanding that the encoder develops of the text, that is the language model, because it has modeled the input into a representation. Are you getting that? The strict definition of a language model is that which the encoder arrives at in its private tongue, in machinese, from the input that it got. Right? But more colloquially, people call the model itself the language model. Implicit is that it has that ability as its core ability. Are we together? Any neural architecture that has that you can conceptually decouple into this state and which creates its machinese representation of input, and from there decodes into whatever it wants to do, is a language model. Right? Now, people use the word large language model. Why do you think the word large is there? Large is an adjective. What purpose does it serve? If you go to a VC and you talk about language models, they may be unimpressed. But talk about building a large language model. You can ask for large funding. I'm joking. Right? See, here's the thing. Large is an adjective. What was large yesterday is puny today. People in the big data world have known this. Right? So don't get carried away by large. There is scale. Be quantitative. Trillion parameter model, billion parameter model, 100 million parameter model. Those are quantitative numbers. But remember, quantitative numbers. But large is an adjective. And its meaning is always contextual to the contemporary definition of large. Right? So you should always be aware of that. And which is one reason in the literature you'll often find just the word language models. People drop the large, and you wonder why. Because popular literature always uses LLMs, but a more formal research literature often drops the word, the L part of that. Right? So now we understood the large language model. Now, what does it have to do with retrieval system? Let's bring the story back. Would you like to see? All of this has to have a purpose, isn't it? Why do you think we went into all of this discussion? Somehow it has to be relevant, isn't it? See, you go to watch a play. There was a time when plays were not on TV. You would actually go in a physical room. There would be a stage. Real actors would come on the stage and they would perform. And there would be, let's say, a living room set, right? And something's happening there. So suppose the set is, in that act, there's a set and there's a living room scene. And in the wall of the living room, you see a gun hanging, right? Prominently. What can you deduce about that play? Sooner or later, somebody will take the gun and point it at somebody else. Right? So, in the same way, the reason we went through this discussion is we are going somewhere with RAG. Right? So, let's start bringing the story home. What happened is Google, the giant of search, they came out with this interesting paper, a remarkable breakthrough. They said that, see, our search is good, but could be better. Our translation is not good. Actually, those of you who remember the world 2015, 2016, the good news about translation was you could get a sense of what was written in the other language. The bad news was you weren't quite sure whether the translation can be trusted at all. You remember that? One of the clearest antidote to depression would be write something in your native tongue and ask Google to translate it into English or Microsoft Bing or whatever it is. And you would get something pretty hilarious. Those of you who know Hindi try to make, in those days, one funny story was, try to make it translate the following. वो चक्कर खा के गिर पड़ा. And then it would come out, for those of you who don't know Hindi, he ate circles and fell. That's right. Which completely misses the meaning. You can see, you have the mental picture of somebody standing with a plate of circles. It reminds you of jalebis, right? So it was bad. Right? In other words, there was a huge scope for improvement. So they started a project. This field was called natural language processing, NLP. Notice the word P, processing. There were neural architectures called recurrent neural networks. There was another neural network called convolutional neural networks, which was wildly successful for computer vision, but also mildly successful for natural language tasks, right? Like translation. So they said, we need to really solve this problem. And how do we do that? We know this partly works, recurrence partly work. Let's start bringing them together. Attention, the concept of attention had just been discovered a couple of years ago. And what people were finding is that if you build an attention neural network module, it acted like pixie dust, right? It was, or think of it as like delicious spice. Whatever you sprinkle it on, that neural architecture started doing better. It became one of the things that you would add as an advanced feature to your existing neural networks, to your convolutional neural networks, to your recurrent neural networks, to your feed-forward networks, to get amplified effectiveness. Are we together? Just as most of you would not want to boil lentil and vegetables and call it sambar. You need your spices, right? But you would also not be foolish enough to just throw in spices and water and call it sambar, isn't it? You would say, well, where are the ingredients? Spices don't just make sambar, isn't it? Are we getting the intuition here, guys? So the basic idea was everybody looked at attention as that pixie does, that spice that made the soup much better, right? Or imagine that you're doing noodles. You don't want just to steam the noodle. You do need to add some sauce to it. Otherwise, it doesn't taste well. But the sauce doesn't make the dish. The general feeling is, isn't it? Like you don't want to drink a bottle of soya sauce and call it noodles. Right? So that was it. So these people, they said, okay, we know we will create the ultimate architecture. It will have CNN, it will have RNN, it will have attention. And the humble feed forward network was implicit because it's like the peanut butter between between the layers of bread that you always put. So you don't count that. They said, okay, what? Yet they were literally throwing in the kitchen sink. Right? What do we call this architecture? They said CAR, car. But we are Google. Go. So they said we are creating CargoNet. And it worked. They had everything under the sun they knew could work. And they built an architecture with all of them thrown in. Right? What do we call that? I suppose in the West we call it a casserole, isn't it? In which you just throw all sorts of ingredients into the pot. And so this is the equivalent of a casserole. Then, khichdi. Then what you do is you try to do ablation studies. Ablation studies, how relevant was CNN to the success? How relevant was recurrence to the success? Did it matter? Or it didn't matter? How much did it matter? It's an attribution game, right? So for example, 3 of you make a company successful, 3 partners. Everything goes well till it becomes successful. The moment it becomes successful, all 3 partners fight. It's an attribution. I did more than you. I need more than you. Same story, right? So you need to do ablation studies to figure out what would the contrafactual be? What would it be without the CNN, without the RNN, and so forth? So people knew that CNNs are sometimes used for recurrence. So I'll just write it CNN, RNN, attention. So first they took out, let's say that, and I'm just doing this, they took out attention and they realized that, yeah, performance goes down. Everybody knew that attention is the pixie dust. It really spices things up. We need to keep it. Then they went to CNN. What they observed is if you took out CNN, nothing happens. Right? No damage is done. The model is equally good. Language model is equally good. So was that a surprise? Not really. The CNNs were mildly effective in natural language processing. So they thought that maybe RNN and attention do the job. Right? Then they said, so the orthodoxy in our field was CNNs do vision, RNNs do text AI, right? Natural language processing. You need RNNs. So they thought when we take out RNNs, the sky should fall, isn't it? The whole architecture should just blow up. It shouldn't be able to do much. But to their great surprise, when they took RNN out of the story, what was left behind? Only attention. It's almost like you're boiling water with just spices. Right? And what they found is to create powerful language models, attention is all you need. And therefore, the name from a paper that would have originally been called CargoNet, right, became the landmark paper. Attention is all you need. But the way I explained attention, and today I didn't go into the mathematics, which I keep for the hell part of the course, when you actually register for it, the deep coding and projects and hell. But I hope I convey to you the intuitive idea. What is attention? If each word is searching for its full meaning and is finding its meaning, right, then the whole text swells up with meaning, with semantic thing. And therefore, it becomes much easier to do as lossless semantic capture as possible. Are we together, guys? Right? That is why, that is the germ of it. Now comes this, why vectors? Why semantic capture? See, why vectors? See, what happens is we may say the same thing, but each of our personalities are different. We may say it differently. Some use rather long words. Some are brief and use simple words. Some are verbose. Some use active voice. Some use passive voice. You may all be saying exactly the same thing, isn't it? So we need something, some concept of proximity. Right? When we ask a friend to explain, we explain something, and we know what he should be saying. We are testing the person's understanding. So the person says something, like you guys gave your different definitions of a language model. Some of you were closer to the correct definition in hindsight. Would you agree? And some were a little bit further off. So whenever we say semantic meaning, the meaning of things, it comes built in with the notion of distance. Isn't it? Distance implies a space that admits the concept of distance, isn't it? For example, Los Angeles is closer to San Francisco than Boston is. Right? So there has to be some abstract space where we can say this text and this explanation of language model was closer to the real one, that was a little bit far off, and that was even further off. Isn't it? For such spaces where distances are there, it is far easier to literally think of a space where a text is represented by a point. Right? Now, here comes the uncomfortable fact. The moment you think of a point in a space, let's say that I think of a point, our first temptation, let's say the point P is there and Q is there, 2 points, and let's say that R is completely separate concept, is way off the mark. And we want to convey the concept of distance. We invariably, this distance concept we do, but we impose a coordinate system on it, isn't it? We'll say delta x square plus delta y square square root. Is that the notion of distance? Euclidean distance we are familiar with? Right? We bring that in. What we are doing is we impose a coordinate system. And these points become synonymous with vectors because if we connect it to the origin, then vectors are what? Do we remember vectors from school? They're arrows, right? So in Eastern mythologies, there's a lot of bow and arrows. So you can claim that they were very fond of vectors. Right? And a vector has a tail and a head and a magnitude, a length, a direction. Right? So the tail implicitly was the origin, the head is the point, and the direction is therefore construed from that. Make sense, guys? Right. So that is why they also become this. Though I must also say that this is the way basic machine learning books and AI books tend to represent it. They impose a coordinate system and they represent it as vectors. There's a concept in learning. It was formulated by a great educator, and the concept is called lying to children. It's not meant to be derogatory. It emphasizes the concept that we all learn by first picking up an easier concept in the neighborhood of the truth, which is far easier to pick up. We know that it's not correct, but to the children, you first teach that. Then gradually, when the child has reached that far, you move the goalpost a little bit further, right? Then the child reaches that, and you say you're not done yet. You keep moving the goalpost, right? And finally, when the child has reached the real goalpost, you celebrate and give him a PhD, right? So something like that happens in our field. In the kind of calculus that's taught in high school, a vector and a point are considered the same. It is partially true. The implicit assumption is the vector is rooted at the origin. Right? But the way AI is being rewritten rapidly now, and obviously the engineering crowd is gradually waking up to it. You must see January 1st, DeepSeek dropped landmark paper. What was it called? Manifold constrained hyperconnection. The word manifold, the kind of people who talk such big words, manifold, they belong to a field called differential geometry. Right? And it turns out that this field is again directly related to what people are realizing AI is. AI, in a more formal sense, is information geometry. See, you can learn hundreds of complicated algorithms and hold it in your mind and try to understand it. I tend not to do that. When we learn here at Support Vectors, as the name vectors in the name itself would suggest, I tend to give you an information geometry perspective, which is the emerging correct perspective of the subject. Right? So you notice that I took you all the way to this points and vectors. So here's the way to think about it. You can hold on to the notion of the vector. Imagine a globe. I used to have a globe in this room. I think it has walked away. But imagine a globe, right? Think about it this way. There is a text and a machine, an encoder, a language model, somehow puts it as a point in the globe. A similar concept, similar text will be put proximal to it, right? And soon what will you see? everything about, let's say, retrieval augmented generation will be a neighborhood on the globe, isn't it? Everything to do with generative AI will be a bigger neighborhood around that, right? Then there will be another neighborhood for politics, another neighborhood for something else, sociology, another neighborhood for history. Am I making sense, guys? Right? Mhm. No. And that's a very good point. The early efforts, so I sort of skipped over the early efforts. Early efforts were things like Word2Vec and Glove. Those were older algorithms and very good algorithms, though, for their own generation. They tried to represent words with vectors. But what happens when you encounter a word like bank? And language is absolutely infested with polysemy and homonyms. That was the key weakness. So the whole text. So when I am talking to you, a whole paragraph or a few minutes of conversation together forms a semantic unit. Right? I call it a unit of thought, a clear, well articulated thought. And what I'm saying, take a clear, well articulated thought and map it to a point. If somebody expresses the same thought semantically, but using different words, no matter what, put it next to that point, right? But if somebody says something that is a non sequitur, put it far off, isn't it? So that, to be able to do that, is what is called today semantic embedding. Embedding a point, but because the point is also, if you connect it to the origin, a vector. So what happens? You have this lovely journey, a text, and there is some magical engine, AI, that we know of now, a language model. What does it do? It converts it to a text I becomes a vector I. And therefore, you need, now you suddenly, mass of text you can store in file systems or in rows of a database table, traditional RDBMS or MongoDB, pick it. But it turns out that vectors are not good to store in traditional databases because imagine that you have a whole table of vectors. I want to find the nearest vector because I'm looking for a word. Suppose I say, let's take a phrase. Why did the cow feel so happy? Well, you want to retrieve that text and therefore the vector whose indicator is that vector, which says because the cow jumped over the moon, right? You see that. You need semantic proximity to search. You need to find neighborhoods in vector spaces. And relational databases, document databases, they are not good at that. So there was a need for vector database. It turns out vector databases were already well developed way before this happened. There's 3-4 decades of development in high performance vector databases. But they were sort of flying under the radar. They were, specialists knew about it, common people didn't know. But suddenly in 2023, every single startup that was knocking on the doors of VCs was saying, what? I have a new vector database, right? And so vector database became a big thing and it went through a whole renaissance. But now you see the importance of vector database in semantic search. But now think about it this way. How does it differ from traditional search? Traditional search was, it seems, was associative memory. With keywords, you could get some of the documents with its inherent problems. Now you ask, why is this better? Because you're not searching by keywords. You're searching with a unit of thought, a whole atomic, whole well-formed thought. A question is seeking its answer in the vast corpus of knowledge. But those all answers are sitting there looking like points on a sphere. So think about it. It's like Australia belongs to politics, right? Iceland belongs to history. Greenland belongs to US. Right? So things like that. Right? So you could therefore find nearest neighbors and do that. And that, folks, is AI search, semantic search. But does it mean that keyword search, therefore, should be thrown in the trash heap of history? Why? That's a very good answer. See what happens. And so that will end the retrieval part. And I'll give you a 5 minutes break and then we'll go to the generation. See what happens is that people may not. People are so habituated to keyword search, or people ask such vague questions that sometimes there is not enough semantic content in the query. Right? You then keyword search still outshines. Are we together? Right? So if somebody just says bank, a semantic search is lost, isn't it? But a keyword search engine might know that statistically speaking, most of the time when this Silicon Valley engineers talk of bank, they mean a financial bank, right? So that association gives it an advantage. So today what we do is we do hybrid search, which means a query is sent to both keyword search and vector search, and the search results are co-joined. But that is still a very, like I use the concept lying to children interpretation. The full implementation of RAG is actually amazingly intricate and complex. There's a lot going on there. But I would end this topic. I know you all need a break. I'll end the topic with one question. This sphere is true, this vector, but what dimensional vector? Two-dimensional or three-dimensional? How many of you for two-dimensional vectors? Why two? It's more intuitive. How many argue for three? Or how many of you are suspicious that I've laid a trap for you? Okay, so let's illustrate it with an example. Suppose you are talking, you're talking about things. You're talking about cows and ducks and horses, right? So you may say, let's see look at the meaning of cow duck. Suppose I have two axes. One is the size and one is the weight, right? So clearly, cows are big and heavy, right? Cow. Maybe a horse is somewhere in the same neighborhood of size, but not so heavy. Horse. And let's say ducks are tiny little creatures. Duck is here, right? Two axes are enough. But the problem is just two attributes, weight and size, are not enough. You don't want to call a sofa a cow or the other way around, right? You will learn the hard way if you ride a cow that it's not a sofa. Right? As kids, if you grow up on the farm and you ever try to, you can ride a buffalo, but you can't ride a cow. Am I right? But you can ride a horse, right? You can sit on a sofa. But let's say sofa. So just between cow and horse, there are multiple differentiations, right? One is rideable, one is not. So you say we need one more axis, right? But then you realize that cows, horses are living things. Sofa is not. You need one more axis. You're already going to 4 dimensions. Do you see that, guys? So what happens is you realize that if your dimensionality is too small, it simply cannot have a good semantic capture. Does that make sense, guys? Intuitively, you need a rich dimensionality to really capture the essence of what is said. The full color, the whole saturation, the color, the texture of a thought to be fully captured. You need enough dimensional space, high dimensional spaces. But high dimensional spaces are weird. They come with their own problems. There is a problem And there is something magical about high dimension. So it comes with a magic of its own and a problem. The problem is well known in the AI community, and it is one of the most dreaded curses, a curse that is far more dreaded than any Harry Potter curse that you read about. Right? Can you name what curse it is? The curse of dimensionality. Right? What it says is something this way. See, and I won't give you the mathematical derivation, but take it as a fact. In Bay Area, if you're talking about your neighbor and you want to talk to your neighbor, you stretch your hand from your window and knock at your neighbor's window, isn't it? And you have a conversation. But in Wyoming, to talk to your neighbor, you get ready, get into your pickup truck, drive an hour, and then you meet your neighbor. So, what is the difference between Wyoming and here? Neighbors are far apart, distances are vast. So, in higher dimensional space, they behave more like Wyoming. Everybody is far off from everybody else. So, the concept of neighbor begins to break down. Are we together? It doesn't really make sense. The other weird thing that happens is basically everybody is really far off from everybody else. That creates this problem. Euclidean distance doesn't quite work, right? Our intuitive notion of distance. But we are used to one more notion of distance. Going back to the stars that I talked about, when you lie down and you look at the stars, don't you say to your friend, look at that star next to that star? Is it actually next to that star? No. They have astronomical distances between them. And actually, that star may be closer to this star, which looks far off. But in angular distance, they are closer. Right? Another way of saying, if I were to remove the radial aspect of it and only focus on the angular separation, I'm using that as my notion of distance. Isn't it? Are we together, guys? It turns out that this notion of distance survives in high dimensions. And in fact, is the preferred notion of distance. Right? Now, the curse of dimensionality is there. You can't go to very high dimensions because no matter what notion of distance you use, everything becomes like you get into trouble. You can't use very low dimensions because it won't capture the texture, the whole flavor, the meaning of the thought. So in between is a Goldilocks region, right? The optimal region. You know the story of Goldilocks? Anyone? Goldilocks region? Okay, optimal region in between, right? The middle path. Not too hot, not too cold. Exactly. That's the Goldilocks region. So the Goldilocks region, or the middle path, which is best, is typically between 100 dimensions these days, up to about 4,000 to 8,000 dimensions. 8,000 is pushing it. Most of the so-called embedders, they stay in this range. Now, there is also a beautiful mathematical fact that people don't know, which actually is the real reason RAG works, search works, AI search works. It goes with a beautiful name called the concentration of measures. Right? It's a very peculiar thing. I'll just give you a flavor of it because we cover it properly and we see actually how your search results when you deal with real documents, finance documents, this, that. Being aware of this and reasoning through this geometry radically improves your RAG performance. You can almost call it the best kept secret in the field. It is this. It's called the concentration of measures. It is this peculiar thing. You pick any vector randomly. You can do this experiment. Just generate 1,000,000 random vectors of dimensionality d. Take d to be, let's say, 1,000. Pick any one vector and find its angle with respect to all other vectors. You know what you'll find? Most vectors will be perpendicular to it. What? How did that happen? It's certainly not true in a circle. It's certainly not true on a sphere. But in high dimension, you take any vector And if they are random vectors, everybody else seems to be avoiding it. So if you think of it on a sphere, on a globe, as the North Pole, everybody has run to the equator. So it is banding around the equatorial plane. Right? It's a very interesting paradox. But remember, I use the crucial word random vectors. Bring it down to earth. If I have lots of random facts and thoughts, etc., then what it means is that any one thought will automatically be far away from random thoughts, unrelated thoughts, isn't it? They will be almost, if it is on the North Pole, they will be separated out and occupying the equatorial plane. Really, really huge angular separation. And that is the boon. That boon is what makes AI search and RAG actually possible. Because now what can you do? If something is relevant, genuinely relevant, so given your question is a thought, the answers, those documents that are truly relevant, they will be there. So suppose you have this equatorial plane. Suppose this is your question here. What will happen is you look from the center at just this cone, and you will find that everything relevant is tightly clustered in a small region, tight region. Right? Think of it as a Hawaii-sized little region on the globe, right? Next to that query. So what does it mean? You have a very good separation between what is relevant and what is irrelevant. Wouldn't you want to have that? Isn't it? So this mathematical phenomenon is called the concentration of measures. It's one of those delightfully beautiful geometric ideas. You see how simple the idea is. Literally higher dimensions give it to you free. They say there's concentration of measures. So if your vector embedding is in high dimension, then you get this. And therefore you can do very high quality searches for relevant documents. Right? Yes. Yeah. Nothing. Nothing. The unfortunate reality is, if if I were to ask you, is there a person in the room who has not used a vector database? Not a single hand will go up. If I ask, oh, there's one person. Okay. If I ask a question, so I stand corrected. If I ask this question, how many of you know how to be aware of this geometry and then shape your storage and retrieval? Once again, no hands will go up. And yet, as you will see, in quite literally the very first week of the more serious course, the hell course that I talk about, is you will see for those people, see people who have done RAG come off into that course. And their first reaction is, so why didn't anybody tell us about this before? Right? It's there. There is there are multiple ways to explain. Uh, in my most depressed moments, I call it the epidemic of laziness. But a more realistic explanation is math or its appreciation and how deeply it impacts your practical results in RAG. That appreciation is missing. People don't realize. They treat it as a black box. They treat it as libraries. Remember the core message I said. If there is a takeaway message from this class, take away this. It is not a trivial subject. It's not a library. It is a whole subject that you need to approach with humility, patience, and effort. It's a big subject. And this is the beginning of that big subject. So this was about the aspect of, and that explains why you see vector embeddings in thousands of dimensions, right? It's the explanation of it. And there's a whole lot of architecture and machinery around it, which dimension, why that dimension, etc., etc. In the RAG course, the formal course, you go through a lot of that. And people have come here, leaders, people leading AI efforts in their company, and they have gone and had an immediate impact in their workplace. That's the beauty of this. When you look at things from first principles, from foundations, you walk on very sure footing. You know what to do. You're not just hacking and doing trial and error. Right? So that is there. So guys, I would like to give you uh, 9 o'clock. Is it okay if we take a 5 minutes break? And then now that we have done the retrieval part, let's go to the generator part, finish the story. That's a shorter story. Should we do that? Let's take a 5 minutes break. Final thing. This is your coupon, Rag to Riches. If you use this coupon, then for the upcoming Enterprise Rag course, you get $100 off. My team has asked me to project this on the screen for you. So there it is. Anybody needs to take a picture or should I move on now? I'll move on. All right, guys. So we understood retrieval. We understood the power of retrieval. And we realized that to do RAG properly, there's more depth to the retrieval system than you thought. It turns out that when you think of generation, once again, there is a lot of depth there. And I'll just sort of touch the surface of it. See, when we look at the word RAG, retrieval augmented generation, there are two perspectives. Perspective one, add on to search. And perspective two is augment language model or generation, a fancy way of saying what you would say LLM with a search engine. Roughly speaking, these are two ways of looking at it. What do I mean by that? Let's look at perspective one. Let us say that you are part of the search, the retrieval industry, search engine industry. Think about it this way. User asks a question, some basic question. What's the difference between a giraffe and a zebra? What does a search engine do traditionally? Even with AI search, it will tell you the most relevant documents that will answer your question. Those documents may be URL, web pages, it may be actual documents or paragraphs or text. But does it answer your question? It does not. It just says, your answer is here, go read it. Yes. Not necessarily, vector search also. You'll see it tomorrow, multimodality. So what I'm saying is, when I said a text, okay, this is actually a good segue. Text, image, video, etc. Our encoder will convert all of these into a vector I, right? So what it means, just to your question, that given a semantic unit of thought, see, a picture expresses a thought too, right? For example, a girl holding a kitten in her hand next to a fence, lot of words to say something that can be immediately represented by a picture, isn't it? So it has semantic content too. The encoders are able to convert that semantic burden of that text, that image, that video completely into vector. Now, in a database of vectors, we can search for which vector is closest. Therefore, we know which pieces of which documents, because where is this text? It is coming from DI. The DI is either a, and by the way, in this world, here's something very funny, and you have to be aware. When in the world of retrieval, people use the word document, they actually don't mean document. What they may mean somewhat like I'm reminded of the story Alice in Wonderland. This girl, Alice, falls down a rabbit hole, goes into a strange world, and Humpty Dumpty is sitting there. And she asks Humpty Dumpty, "What did you mean by that?" And she says, "I mean by that word whatever I want it to mean." Right? It's a funny thing for children's story. In the same way, in the world of AI, when people use the word document, they may mean an image, they may mean a video, they may mean a text, the whole content of a document as text, or they may mean a paragraph, or they mean a chapter, or they may mean a sentence, or they may mean just a word, right? Everything is fair game and comes under the umbrella of document. But all you know is somewhere you have kept your metadata point, somewhere you have kept a connection with document ID of I and the document I, whatever it is, image, whatever it is. And so this when it gets translated because of the embedder, now you have a document ID I and a vector I. That is what that's what the vector database is sitting on. Are we together? So when you search it with a question, what you end up with, the vector database says, I'll tell you which document IDs contain content proximal to this. Right? It is your job to then go wherever you store the documents to go read those documents. Right? And those documents could be images, videos, text, chunks of text, etc., etc. That's how you think here. Does that answer your question? Okay. Now, when you do search, it doesn't tell you the answer. I asked for a question. How does a zebra differ from a giraffe? But it says read this, read this, read this. Language model, on the other hand, its core strength is it can read, understand. Language models are the language model. If you go back up and look at the original picture that I drew, when I said that language models do a lossless semantic capture, isn't that a fancy way of saying they understand language? Simple way of saying. That is why the proper name of language model, and in some literature you find it, language models are called language understanding models. Right? And by language, it could be text, it could be visual, audio, etc., etc. Because we live in a multimodality. In the more formal course, you learn how to do all of that. But that is that. So language understanding. But if a language model can understand the language and answer your question, then doesn't it make common sense that now that you have a search engine, why not screw in a language model on top of it and get the whole answer? Why do I have to read the document? It can read it for me and answer my question. The search engine tell me which relevant documents to read and let the LLM read it and answer my question. We do it all the time. Don't you upload these documents and say, here's my question? Right? So that is one way of looking at RAG. In that case, the LLM augments search and completes the whole use case. There is another perspective of it, which is the perspective we'll come to, generation point of view. LLMs had a problem. These LLMs are horrendously expensive to build. They are the neural scaling laws that say the bigger the model, the more data you need to train, the more compute you need to bring to it, but the more capable it will be. Right? So one of the cheap or sort of a cheap way, so if you have lots of money, right? If you have deep pocket, then easiest way to scale up and achieve a better model, more powerful model, is simply to bring more compute, bring more data, and throw more neurons into it, more parameters into the model. All right? High parameter model. But when you do that, it takes months to train. Right? Suppose you took data up to today to train the model. Now two things happen. First is that model. Let's take this situation. In the last presidential election, one of the parties changed their presidential candidate midstream. I believe something like August or something like that they changed. The Democrats changed, right? Before that, it was Biden. Then it became Kamala Harris. Right? Then, suppose you ask this question to a model that was trained with data up to August. Who is the Republican candidate? Answer would be correct. Who is the Democratic candidate? And the answer would be wrong. Because there is a staleness factor to the data, isn't it? It's stale. Language models are dated. They have within them compressed knowledge. They don't have actually verbatim knowledge, but they have compressed representation of information. They would come out and say, well, it's Biden. Are we making sense? So, staleness is a problem. Now, you can't keep updating the LLM every night. But search systems, you can keep updating it every minute. Documents keep coming in. You can keep vectorizing it, putting it into your vector database as a continuous stream of data that never stops. Are we together? So the question that comes, why not, given a question, rather than going straight to the LLM, which may be wrong, first search relevant information. Let's say that you have a database of news items, pick up the right information, pass it to the LLM, and tell it with a system prompt, guiding prompt, or instruction prompt, use this information to answer my question. Right? Because then what are you saying? I trust my knowledge base more than this LLM. So LLM comes with two things: language understanding ability, which we love, but for this situation, we don't like the other part that it comes with. It comes with world knowledge. Right? And sometimes that knowledge may be stale or incomplete. Right? You are telling the LLM, use this information, I trust this, to then understand it and answer my question. That is the other perspective of right. So what are you doing? You are taking the generation, the LLM's role, you are augmenting it with what? A search engine, right? Or retrieval system. And that is why the word retrieval augmented generation has become, RAG, has become the default name for this whole field. Right? There is another problem with LLMs. I'll put it humorously like this. Have you ever given a problem that you throw at an engineer? Have you ever come across an engineer who says, I don't know how to do it? Right? The first reaction would be, yeah, give me 2 weeks, it's done. True? We are pretty confident creatures. Right? How do you integrate consistently relativity and gravity, relativity and quantum field theory? 2 weeks. I'll write the code and make it happen. Right? With libraries. So anyway, I'm joking. And these LLMs are the creation of engineers. So they are also very confident, just like us. So what happens is when their knowledge is patchy, they don't say, I don't know. It is very, very hard to make a LLM say, I really don't know. Right? But when it doesn't know, shouldn't it say it doesn't know? Isn't it? What it does instead is it guesses. It's a plausibility engine. It comes up with the most plausible, most likely answer statistically, right? And confidently tells you a story, right? Which is wrong. So you don't know. Of course, you call it a hallucination, but hallucination is not acceptable in a corporate setting where stakes are high, in a medical environment, right? Or in mission critical situations. You cannot have an LLM hallucinate. So you need to make sure that it is given all the facts so that it is easily able to answer the question rather than guess the answer. Does that make sense, guys? That's another reason to do the retrieval augmentation. But there is a third aspect to it. I alluded to it. In spite of all of this, as you will notice, the LLM may not only derive the answer from the search results. Remember, it has its own memory, parametric memory, and it may choose to answer the question from its parametric memory, right? All that it remembers. And there's a very, well, today is not the lab, but I wanted to show you, maybe I'll show you this example, or maybe it's a distraction today. Let me see, there's a code. I wanted to show you. Where did that go? No, not this one. Okay, let me see. So this is for tomorrow, but I'll just give you a flavor of it. We'll run the code tomorrow. Let me remove all this. See, I give this a document, and this is how RAG can be misleading. Most people think so easy, right? Read this little library documentation, and then you'll be done. And so I give it a data, Greek world history. You notice that I give it a book or chapter which is about ancient Greece or the Greek world, right? I take this document, I shred it, I give it to the LLM, to a RAG system, and I give you a code. And this point is worth making. This is basic RAG. Actually, let me remove all the clutter from here. How do I maximize this? Oh, okay. So this documentation, by the way, comes from one of the very popular RAG libraries, Llama Index. Excellent library. Yeah? So this, by the way, is not a criticism of the library, but it is just showing what happens when you blindly use libraries. So, and I'm literally taking the code verbatim from them, more or less. Document, give it a directory reader. It says, hey, give me the directory of documents. I'll read it. After that, go at it. Ask questions. That's all there is to RAG. Right? You may think. So I do that. Vector store, see one line, line 22, produces for you the document chunks. This creates a vector store out of those document chunks, right? Then you treat the entire index as a query engine, a search engine, and you ask it a question. I'm asking it this question. What are some key features of ancient Greece? Right? So as you can imagine, the system will first go and search the documents, the vector space, find the relevant document fragments, feed it to the LLM, produce the answer. Does that make sense, guys? Right? And I'll run this. And by the way, this is for tomorrow, all of this code. But this is illustrative. So zoom in a little bit hard because I don't have much keyboard control at this moment. But let me try. Oh, let me try this one. Okay. Better? Okay, here it is. It came up with an answer. Some key features of ancient Greek civilization included their architectural innovation, blah, blah, blah. So it looks pretty plausible, right? It seems to have taken facts from the document and given you the answer. Would you believe that, guys? Looks plausible, isn't it? Now, I play a game with it. And this is a game I want you to learn to play with your RAG systems to know what really is happening. This is a chapter on Greek civilization, Greek history. Does it say anything about Chinese history? No. Or Indian history? No. Suppose I say Chinese civilization. Theoretically, it has no business answering this question, isn't it? A good RAG system would say, I don't have the info. But what does it do? Let's go. Okay, let's go. Oh, look at this. It very nicely answers your question. What do you think? Is this how a RAG system should behave? No. It was supposed to be faithful to the knowledge base you gave it, isn't it? Instead, what did it do? Not getting the results, it dipped into its own memory, its own world knowledge, and answered the question. Now, what are the practical implications of this? Here is a failure mode. This actually happened. Not to name the company, but one of our giants in Silicon Valley early on implemented RAG for customer support. Customer asked, right? Oh, maybe it was a network switch or something. Do you have a network switch, that networking equipment that does this? So the LLM said, no, we don't have it. But you know what? And what we have is not that, doesn't fulfill your requirement. But by the way, our competitor has, it named the competitor. They have excellent network switches that you should go and buy. Now, you don't want your own platform to be the marketing and sales for your competitor, do you? Right? It is a failure mode for the RAG system, isn't it? It's exactly this problem, isn't it? Right? And folks, that is the problem with naive RAG. That's the problem. When you trivialize RAG, or you think, hey, I can use a library and that's all there is to it and I can build RAG systems. I'll take questions in a minute. The lesson I'm coming to, guys, that RAG looks deceptively simple, but it's one of the hardest piece of engineering to build correctly. It can hallucinate. It can give you answers that you don't want it to give, right? See, when you look at the likes of Perplexity, they have a really good RAG system. But what do? Every answer is grounded in what? Sources. They give you references. So what you need to do is build a RAG system which from day one, the moment it produces an answer, you disentangle the answer and extract assertions from it, facts from it. And then you ask an AI agent to adjudicate whether this fact is grounded in any of the search results, any of the documents that the search returned. And if it's not, then you're only half done. In the world of retrieval search, there's a concept of exploratory search. That search is iterative. You ask for something, you get approximate results. That helps you think more and ask more precisely. So what you need is an agentic system that is hovering over it and looking what's going on. Getting the result, it starts adjudicating the facts in the answer. It starts grounding the facts in the actual search results. And if it fails to do that, repeats the process. So in reality, RAG is never just a generator, LLM screwed on top of a search, which is the way most people think of RAG as baseline RAG. That is the way 99% people implement RAG in the enterprise, because that's wrong. Right? And that really is wrong. You want to build a system whose key feature is not willingness to answer, but caution that says, I do not know. You know you have built a good RAG system when it can be honest and say, given the facts, I do not know. Are we together? Because that is important. Then you know it has not hallucinated. Then you know that your facts don't have the answer. You can go search for those documents. Am I making sense? So the world of RAG has a lot of very interesting. Think of a zoo like the San Diego Zoo, right? And it has a lot of exotic animals, wonderful animals and creatures. And you get introduced to it when you actually build something on the scale of Perplexity or any chat GPT or something like that. So now in enterprises, you never do that. You don't get the web scale traffic that Perplexity gets, or chat GPT gets, or Gemini gets, or Anthropic gets. But at a much smaller scale, that of an enterprise or that of your startup projects, you can still achieve the same quality, the same precision, the same trustworthiness in the rack system. But that doesn't come by not knowing the subject and just using the libraries. Am I making sense? So, guys, I'll end today with a parting message. There was a Russian writer, all of you are familiar with, Leo Tolstoy. He was an interesting person. When he was young, he was madly in love with a girl. When he married her and he was in his honeymoon, he decided to write a novel. That novel is a famous novel. It's a great classic called Anna Karenina. How many of you have read it? It starts with a famous sentence. And that book ended up being one of the strongest damnations of marriage itself. Right? So it's a very sad story. It starts with the following line: all happy families are alike. Each unhappy family is unhappy in its own unique way. Wherever there is dysfunction, you get to hear a different story. I would like to end this with the fact that all enterprises around you, you wouldn't be able to find an enterprise that doesn't claim to be doing RAG. Everybody is. Within an enterprise, there'll be 50 teams doing RAG. What are you seeing? Unhappy families, unhappy RAG implementations. Because done well, uncannily, most well done, well architected enterprise RAG systems, they look uncannily similar. Right? Whether you're talking about Perplexity or ChatGPT or within your enterprise, the underlying blueprint looks uncannily similar. But it turns out that that blueprint is not there in typical textbooks from the usual publishers. Most of that knowledge is buried in research papers. So what we do here at Support Vectors, and forgive my one moment of a few minutes of spiel, what we do here is we distill our experience of years in building actual enterprise class, very robust rack system. And we distill all the research papers that our team has been reading. And our team is quite high powered. There are a lot of brilliant people with IIT and then a US PhD and years of experience. We distill our life experience and the research papers we read into a blueprint that we know works because we have made it work for very, very serious enterprises. And this course is about sharing that blueprint, those best practices, those design patterns. I'll end with that. So tomorrow, guys, we'll do the code. I'll walk you through all of this code. No. The hallucination not it's a inherent quality of the LLM. When it is not sure of the answer, it will hallucinate. No, it does that, but it can be creative without hallucinating. The only place you use hallucination is actually to prove math theorems. Sometimes when you don't know the answer, you deliberately force the LLM to hallucinate and come up with creative, like very odd ideas. Yeah. Not necessarily. You'll get more creative answers. And the chances of hallucination do increase. All right, guys.